Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is count the number of incremovable subarrays. So in this question, we're given a zero-indexed array of positive integer called nums. A subarray of nums is called incremovable if nums become strictly increasing on removing the subarray. So for example, 3, 4 is an incremovable subarray of the bigger array 5, 3, 4, 6, 7 because if you remove these two elements, it will become 5, 6, 7, which is an increasing subarray. So 3, 4 is an incremovable subarray. And we have to find the total number of incremovable subarrays of nums. So subarray is a contiguous non-empty sequence of elements within the array. So there shouldn't be any gaps or you cannot remove elements to form a subarray. That would be a subsequence. So let's take the input given to us. 1, 2, 3, 4 is the input given to us, forming incremovable subarrays by forming subarrays from the 0th index. So if we remove the 0th index, you get 2, 3, 4, which is an incremovable subarray. Now you cannot remove this because it will give 1, 3, 4, but this is not a subarray, it is a subsequence, so you cannot count this. Similarly with this, 1, 2, 4 will not be a subarray. But here if you remove 4, you will get 1, 2, 3, which is a subarray and it is also incremovable. Now let's remove two elements. If you remove these two, you will get 3, 4, which is an incremovable subarray. If you remove these two, you will get 1, 2, which is also an incremovable subarray. If you remove these two, you will get 2, 3, which is also an incremovable subarray. You cannot remove these two and form 1, 2, 4. That is not a subarray. Now let's remove three elements. This is a subarray. So all single elements are going to be subarrays. So 3, 2, and now the entire thing is also a subarray and it is also incremovable. So we can consider that. So in total you get 10 incremovable subarrays. So this is the output. So as I have displayed, let us implement the same steps using nested for loops and form subarrays. So we start with I and j both pointing at the 0th element, and j will be moving forward and forming subarrays. So we are going to use these as boundaries for subarrays, and once we get a subarray, for example 1, 2, 3, so if I is pointing at 1 and j is pointing at 3, 1, 2, 3 is a subarray. Now I'm going to check if it is increasing. To check a subarray if it is increasing or not, I'm going to write a helper function and use a previous variable. I'm going to use a variable I which is pointing here, and I'm going to check the I and j index if they are of a valid range. Previous element is 0, so I'm checking if 1 is greater than 0. Yes, I move further and I update previous with the current element at 1. Now I check if 2 is greater than previous is 1, yes. So update previous with the current element and move I. Now check if 3 is greater than previous 2, yes. So now move I. And I reach the end of the subarray and all the conditions have passed. So this is an increasing subarray. Now let's implement these steps in a Java program. So this is the helper function which I have written, which I am going to call in the main function. I'm creating a variable count which will count the number of incremovable subarrays, and finally I'm going to return that variable count. Find the length of the input array, and I'm using two nested for loops. Outer loop is I and inner loop is j, which starts from I, and both will iterate till the end of the input array ARR. And I'm calling the is increasing subarray for that array and placing the start and end index. And this helper function will return a boolean value true or false, denoting if it is increasing or not. It will return true if it is increasing. It will return false if it is not increasing. Create a previous variable, and I'm using a for loop to iterate from 0 until length of the input array. I'm checking if the index of I is less than or equal to end and greater than or equal to start, because as I mentioned, the subarray can be invalid. Now I'm checking the false condition. If current value at I is less than or equal to previous, then it is not increasing, right? Equal to will check the strictly increasing condition, and less than will check if it is increasing or not. If this condition passes, we will return false. And before starting the next loop, I'm assigning the current variable to previous, so that we can compare the next increasing element or not. And finally, outside the for loop, I will return true, which is denoting that subarray which is passed here of range I, j is true. If it is true, we'll increment count. For this, count will become 10, and once the nested for loops end, check for all the subarrays, I'll return count, So count will return 10 for this example. So the time complexity of this approach is O of n cubed because we are using nested for loops and then a for loop to check if it is a sub-array or not. And the space complexity is O of 1 because we are not using any extra space to solve this question. That's it guys. Thank you for watching and I'll see you in the next video.